Okay, so this is a bit of a more in-depth view at the node software. We've seen a lot of this before. It has the EOSAO database and multi-index tables, has the WASM virtual machine, has an interface to connect these two called the WASM interface, and has several plugins that run different parts. These are all optional kind of plugins as to how you want to run the node. Specifically, these two run the protocol, and you don't need to run the HTTP API that lets you send transactions to a node to run that. So this protocol can be run in a very lean way without a lot of the other overheads that you see in other blockchain protocols. That's what allows this to be more scalable than most other blockchain protocols. Is you can turn off a lot of the other features, like, you know, this API does a lot of JSON passing. It takes a lot of memory to do those kinds of operations. So you can run a very lean protocol that doesn't have to manage that kind of stuff. Whereas this, other nodes can run, you can connect to it, and provides much better compatibility with web apps for usability features.
This is open source. The C++ implementation of the Node OS is...
And you can write your own plugins. They've got a whole class definition for it that do all kinds of cool things to customize it. So they make it very modular in that way. So yeah, that HTTP API is actually what we've been using in EOS Studio. We're not directly communicating at the protocol language. We're communicating with the API, which knows how to translate it into language. And then that runs the protocol at a very lean level. The nodes in that core are probably not running an HTTP API. That allows them to be much more performant.
So you are communicating with the node outside of the core, which in turn communicates with the node core.
Which we saw in that kind of network topography layout. It's an important part of how it manages to be quite performant, more performant than other places.
So the nodes outside of the core and inside of the core, they communicate with the special protocol.
They communicate with the USAO protocol. They communicate with this, but web apps usually communicate with the nodes with this. That makes it more compatible for web apps. They know how to speak HTTP. They don't need to go and serialize, deserialize data into byte format. It just makes it easier. So yeah, here's just a look at one of those actions. This is the data in an action. You send the account that you need to send to, the name of the action, the data for that action. So here is the system token contract. This is what we send. I'm sending from me to somebody else this many coins with a memo, and you need to set who's authorizing the transaction. So I've covered a lot of this already, but if you want, this is the full transaction structures. I'm not going to do it all again. So yeah, it's important to know that the USAO protocol doesn't need a lot of the extra data that's put in the HTTP protocol. HTTP protocol adds another level of data, which makes it more useful for other people. I'm not going to do that yet. So this is probably more in depth what a blockchain application looks like. So you have a front-end client. This can be a web app, a mobile app. It could be different servers in a private network if you wanted to do it that way. So on a public network, you have a front-end client. They connect to a node with an SDK. So that's EOS.js. If you're doing a web JavaScript application, they usually connect to the HTTP plugin that will communicate with the USAO protocol, which synchronizes it to the rest of the network in that blockchain. And then this node EOS also commits, it updates the database inside USAO, so that's in RAM, and also commits the transaction history to a disk somewhere. The last thing here is that often cases you offload the work of digitally signing to a separate software, to a generalized software that can sign transactions. And that's called a signature provider or a wallet. And this is how, instead of every application managing private keys. You get one app that everybody can trust that manages private keys, that's audited. Otherwise, you would have to trust every app again with your private keys if you put them in. Make sense? So, some very important things. So,
can I
yeah.
go back? So, to communicate with that HTTP plugin, you say that there's the EOS SDK, which is JavaScript.
There's also a Java and a Swift
Okay.
SDK. Those are official ones. There may be other ones, but that covers most apps. Yep. So yes. So at the smart contract level, currently, there's no privacy in smart contracts. There's no built-in privacy. So whatever data is sent to the contract, all of the other contracts can read too. Okay? If it's a public chain, that means everybody can read that data. So you don't want to put things like personal data into a smart contract on a public chain. I know they are now in the ideation phase of building some kind of privacy solution for smart contracts, but it's not there yet. But currently, this is very real. You have to make sure you're putting the right data in the contract. This is why things like hashing are very important. You hash some data and put that on the blockchain, and that can provide some more privacy to that data, while still being able to be verified publicly by other people. I'm not saying that's the end-all solution to things, but
you could mask the data, right? So what do I mean when I say 832? Could mean anything.
Yeah.
Right. So
yeah. So
we interface with the things. Yeah. We now agree that if I'm talking not too nicely, I say 832. You know, you have no idea, right?
So there's lots of different strategies for how to deal with this. You've got second layer solutions on public blockchains that create data up here and then hash it on the blockchain. You've got private blockchains, so there you can actually have the data on the blockchain, but nobody else can read it, and different kind of hybrids and other strategies out there. So the other part is that smart contracts are publicly available to anybody, depending on the rules. And so if somebody finds a bug in that smart contract, they should be able to execute it with little ease. And because these smart contracts, the code is available so that people can verify it, you want to be very sure that it doesn't have bugs, especially if those bugs may cause people to lose currency funds or something. So looking at usage of EOS, right? So this I got yesterday from Blocktivity. There's a lot of different metrics out there. Blocktivity is nice. Blocktivity counts the number of actions on the blockchain. It defines actions as the number of function calls. So why it does actions and why it says activity and not just transactions is because in EOS.io, it has this abstraction of actions and transactions. So it looks at the amount of actions in EOS. And so this was from yesterday. It's still, as it has been for about a year, significantly more use than other chains. Interestingly, these are two other EOS.io chains, Wax and Telos, and they're also in the top 20 at the moment. We can look at a different source, Masari, and here we can also see which chain is doing the most transactions. So they have a filter here, on-chain data, transactions 24-hour. Yeah, and we can see EOS here has the most transactions at a transaction level as well, with Tron next, then Ripple, then Stellar, then Ethereum.
But if EOS is having this much problems, why is it still then so used?
Good question. A lot of those transactions are part of the DDoS attack on the chain itself. But what's yeah. That's the truth.
What's in it for these people who are doing the denial of service?
You have to look at the mechanism. It's a bit too complex to explain right now. There's a thing. Before this attack, they were also the most used as well. It does, on one hand, it shows it's being attacked. On the other hand, it shows it's actually able to sustain a huge amount of transaction throughput load. And actually, this is having a look at several of the popular chains at the moment. So the throughput capacity of EOS-AO, and that applies to both EOS and Telos and several others, used to be about 4,000 transactions per second. Now they've released a new WASM engine, and that's about 6 times faster. So these chains, any chain on EOS-AO can do approximately 25,000 transactions per second, which is just much more than anywhere else. I mean, another thing is these other chains, Bitcoin, Ethereum, they just haven't changed throughput in several years now. EOS-AO has gone 6 times in the last year since they announced the release of this new WASM engine. The other part of the usability of these chains is not only throughput, but how quickly those transactions get confirmed. You have a half a second block time, which just makes using the chain really nice.
Comparing with other blockchains, which is the one that it is currently has the max throughput?
EOS-AO definitely has the most throughput from all of the other blockchains. I think non-blockchain distributed ledger technologies like hash graphs may have different throughput capacity, but I'm not sure. I'm not like very close to that kind of a data structure. But I think in terms of chains of blocks, EOS-AO has the most performant system. Yeah, by quite a way.
Looks like the EOS-IO version 2 is like the same level as MasterCard Visa. It's right up.
Yeah. And this throughput depends significantly on what type of transactions you're measuring, as well as what kind of resource allocation is done on chain, managed by the system contracts. If those system resources are managed badly, then you might not be able to get to this. Yeah, there's different scenarios. We won't go into it. But basically, they should be able to get pretty bloody performant, more than most other things. So transaction fees, this data is actually a bit old, but this was from a few months ago. It shouldn't be wildly different. But basically, a kilobyte of data on EOS with the staking mechanism costs about 70 cents. For a kilobyte of data on Ethereum, it's about 33 cents. To do a token transfer of the currency costs about half as much on EOS. This also depends on who you're transferring it to. If you're transferring to somebody who already has an account balance, it's actually a lot less than this. So Ethereum is quite different to EOS-AO, in that every time you send a transaction, your build and your account balance is subtracted. In EOS, your account balance is not subtracted. You just have to have it staked. So you have to remember to compare these. This does not mean you have to decrease your account balance. It just means you have to have this in your balance. There is a way to rent resources with this REX mechanism, and that takes the cost down to this price for the same amount of data.
You're paying some subscription or something so often to the service.
Yeah. Yeah. So
depends how heavy is the network.
Yep. It depends. Yeah, it's a supply-demand kind of a deal, and it may be different now, but this was a few months ago. It shouldn't be too far off, I guess, in mechanism anyway. So just having a look at different distributions. So this is comparing who actually makes blocks on different systems. So you can see in Bitcoin, 15% of the blocks are produced by just one mining pool. Yeah, it's not too bad compared to some places. EOS has a far more even distribution among 21. You really have to think about what is decentralized here. So something's decentralized both based on who's building the blocks, but also in both these networks, most applications don't connect to one of these nodes. They connect to an application node, an API node. And actually, the nodes synchronizing, the nodes validating the block producers do a lot of the work as well in validating and making it decentralized. So basically, if any of these nodes here in either of these two networks did not play with the rules, the whole rest of the network would just not sync them, right? In Bitcoin, there's about 10,000 nodes that just validate and run a full node. And those are mostly used for applications. So if you're an application user, even if this was quite centralized, which in some cases it can be, you still have a better guarantee than before because the node that your app is connecting to will usually stop syncing if it sees the rules are not being adhered to. Does that make sense? So yeah, there's more to the story than just showing these distributions. So another thing I want to look at, so this is two different proof of stake chains. So NXT is currently pure proof of stake. Ethereum is planning on moving to a pure proof of stake system. It's currently proof of work. But you can see here, this is very interesting, that these are not so decentralized at the block production level. And NXT is a great example of showing that proof of stake does not necessarily make something more decentralized at the block production level. It really depends on a lot of things. So I would hold your breath for what happens with Ethereum 2.0 and proof of stake there. It may, if it comes to life, yeah. But yeah, we'll see. So this was the roadmap that they released in 2019. So the first two things here, they've already built and shipped with EOS IO 2.0. So you've got the new virtual machine library runtime, which is about 6 times more performant. And you've got WebAuth support, which is really nice. It can actually, so WebAuth is support in the browser. So that means you don't actually have to create new browsers with cryptographic primitives for people to be able to use this. That's going to be really handy. They're looking into all of these other things. I know they're actually working on multi-threaded contracts, which is nobody else is doing that. Inter-blockchain communication. They've got this disk resource for number 5 is definitely happening right now. They're talking to me about enterprise use cases and privacy data at the protocol level, and voice.com, an interesting social media platform, is out in beta at the moment. So these guys, build strategy and then deliver. It's pretty cool. They have $4 billion, so it makes it a bit easier.
That's 4 billion is from part of the whatever you call pre-mine or something? Or?
No, that's from the token sale itself, 4 billion. And then the pre-mine gave them an extra lot of money as well. Yeah. But that pre-mine's only on the EOS blockchain, not on the other blockchains. So most of the other blockchains, especially the new ones, are not, they're not supporting the pre-mine that Block One built into their software. Yeah. But the EOS blockchain, the first one, has that exact same snapshot from the ICO, which gave Block One 10%.
Decentralized file store, is that like little bits of files just scattered all over the place and then...
Say again?
The decentralized file store, is that where you can...
No, I think what they're looking at is that new disk resource. So you can store things in RAM, but you can also store things on the disk. And that has a different property. A disk can actually store terabytes of data. RAM is limited to maybe 100 gigabytes on very big computers. You still can't get terabytes of RAM. So I think that's what they meant by here. Maybe they mean something else, but I think that's built into. So now I know they're building this. Once that's released, it means smart contracts will have the ability to store up to terabytes of data that's synchronized across the network. So you've also, this is nice, you can check out the Telos roadmap. This is more about the governance roadmap and how they're planning on looking at it. It's quite interesting as well. So yeah, what's next for you guys? You guys can now understand what's going on and build your own blockchain applications. Yeah, you're starting today. That's exciting. So firstly, how to build a blockchain. You can use existing deployed public blockchains. So you've got EOS, you've got Telos, and there's quite a few more. Or you can deploy your own highly customized EOS AO chain with a lot of different ways to customize that. You can have a public-private chain. You can make it permissioned or not. You can have it decentralized or not. And you can do a whole bunch of crazy customizations that just weren't possible to do before in a very simple way. So Chris and I have a very interesting concept for the Odyssey hackathon that really looks at blockchains in a very different way. That's all I'll say.
What do you use? So you use your own blockchain? Or
No, we're on EOS.
EOS. Okay.
Yep.
Yeah, and the news about EOS that's not so going so well, but new to you or?
No, we've suffered a little bit from it, but it works. It's not that it doesn't work.
Yeah.
Like Jack also said, it's incredible that they still do that many transactions even during this spam attack, but it still works. So we can pay out everyone. It's a little bit expensive, but we pay out thousands of people per month, and it costs us maybe a couple $100, maybe $100, $200 in a month. So it's pretty doable. It's workable for us. We are looking at scaling solutions in different ways.
Sign in